Alright, I'm going to unsolder this capacitor network because I decided in the end to bite the bullet and replace it. And I'll make an effort to make one which looks as much as possible as the original one. But obviously that's not going to be a piece of cake. Well, I just hope I can pull it off because it's really tiny, and as you can see there are quite a few connections going to it or coming from it. It's all a very fiddly job. So in part I'm making this update to show you what I intend to do, and also to have a sort of a visual memory of how the part was connected to the rest of the circuit. So, well, like I said, let's just bite the bullet and get on with it. So I'll be back with another update as soon as I unmounted it and I started making the replacement. And here it is. It's an Opco M106, and as you can see the wires are numbered from 1 to 7. Yeah, it's a bit hard to see because it's faded, and as you can see it's not big, and there are 7 tiny wires coming out of this capacitor network. So I unsoldered it, and well, now I'm going to try to replicate this part, but as you can see it's really tiny. This is the result. As you can see, I managed to squeeze quite a few capacitors onto the board, and the size is pretty much the size of the previous element. As you can see, the size is pretty much the same, except perhaps for this capacitor, which sticks out a little bit. But well, I squeezed it in as best as I could, and I think I'll leave it just like it is. This is the back side. So, well, I think it succeeded rather well. Well, of course, like they say, the proof of the pudding is in the tasting. So, what I'll do next probably is cover the whole board with maybe some 2 components glue or something like it, and the back too, and then I'll start wiring it into the radio. I don't know how I'm going to give it the same appearance, but maybe I won't in this case, because it's full of components with different values, well, slightly different values from the original ones. For example, for the 5000 picofarads or the 5 nanofarad, I used the 4.7 nano, and for the 2 nanofarads I used the 2.2 nanofarad. And then I looked for 2 tiny picofarad capacitors which measured out as closely as possible 150 pico. It turned out, strangely enough, I found 2 100 picos, or rather rated as 100 picos, but when I measured them, their value was much closer to 140 picofarad. I think it was 137 or something like the one of them, and 135 for the other, which I think is within tolerance. So yeah, I think that'll do nice. I'm gearing up to clean the last, well, to clean the most dirty parts of the radio, and namely this this variable capacitor or tuning capacitor. It has quite a bit of dirt on it, and the rubber grommets, which are supposed to cushion it against shocks and all that, well, they are pretty old, and as you can see, one of the rubber rings just fell apart. So these will probably need changing, or I will need to find a way to substitute something else for them. Also, I think it wouldn't harm to clean just a little bit the volume annex on-off button, although I suspect this potentiometer is not as dirty as the variable capacitor is. I'll also unmount these rusted parts, or at least, well, probably this battery holder I can't really unmount, but well, maybe I'll try to de-rust it in another way. Still, it needs some cleaning. Also, this spring, which held in place a battery and also acted as the negative lead. Remember, the whole copper body of the chassis is ground, so this is a hot chassis. So effectively, this spring, which was used to keep the 1.5 volt battery for the filaments in place, does not only act as a battery holder, but also as the ground lead or the negative lead. So that needs cleaning too. Obviously, the contacts for the batteries are a little bit oxidized. Well, this one isn't, but this one is, so that will need a little cleaning. And in fact, strangely enough, the worst part, if we talk about dirt, the worst part of the whole chassis is really this spot, which is, I think, not rust, but rather a sort of acid layer or dried battery acid or something like that. So I will need to clean that off. Also, I remember I said that the chassis is probably solid copper, but now that I look closer at it, maybe I was wrong. Maybe this is copper plated steel. So I'm not sure. I'm not entirely sure, but still, whether it's copper plated or massive copper, it's still nice, and it does make my life a little bit easier cleaning it. I'm not going to test the theory whether the chassis is massive copper or not. I'm not going to drill a hole through it or anything like that. Let's just say that it might be massive copper, but still, whether it is or not, it's okay. So, we're almost in the home stretch. I need to clean up the chassis, as I said just a minute ago, and I need to clean up a few parts. I also mounted a fuse to the chassis, and in effect I had a little bit of luck, because you'll remember this part here is a special kind of rotary switch. This one also needs cleaning, but it doesn't have a knob or anything. So in effect the space above it was empty, and it had just the right amount of free space that I could mount a fuse, which I did. And there was a space cut out of the chassis, which you see here at my thumb, and this space was probably meant to house a switch. Now don't ask me which kind of switch. It might have been an on-off switch or a power switch. It might also have been a place where they intended to mount a band switch. Anyway, since there is no switch mounted here, I managed to splice in a fuse holder, and it looks really nice. I think I succeeded in doing, or rather mounting it without damaging the chassis, and it will protect the chassis against future short circuits and all that, because trust me, sooner or later, whether we like it or not, some part on these old vintage machines will fail and will eventually cause a short circuit. So it's always a good thing, I believe, in AC powered vintage equipment to build in a fuse. We have also a very nice look on the can dome. You remember the 2000 ohms power resistor. It's actually rated for, let me see, 10 watts. So the can dome you see there is in series with the filaments of the tubes. Remember, there are 4 mini tubes on this radio. So the can dome pulls down the current, or limits the current going through the 4 filaments of the tubes. And it measured out okay, so I'm going to leave it where it is. If it fails, I can always replace it by a modern resistor, but I prefer not. I'm really trying to keep this radio as original as possible. Also, I tacked in temporarily these 4 capacitors to test the radio. Unfortunately, bad luck hit me, and when I wanted to put the tubes back, I noticed that one of the mini tubes had lost one of its pins, and more specifically the 1U5. The 1U5's one of its pins, well, broke off, and it broke off just at the glass foot of the tube. So there was no way I could repair it, unfortunately. Alright, so that's what's going to happen to the radio. Now, one final look at the capacitor network which I made. So you'll remember this brown little thing here was the original capacitor network. This is mine. Granted, it's not aesthetically pleasing. Well, neither is the original one actually, but it'll do the trick. And although the leads are rather short on mine, as you can see, they are not as long as most of the leads on the original one. That's not really a big deal. If needed, I'll just splice a thin wire to it before soldering it back into place. So that too is a job that will need to be done. And once the new capacitors I ordered arrive, I will restuff the original electrolytic can and mount it back.